I am Latoya Shiraya.
And I am Karima Mundell Thomas. And we are your teachers for today's mathematics lesson.
Let's start now.
Let's begin.
All right. So today we'll be looking at solving problems involving consumer arithmetic and sets theory. So we're not looking at the regular 1 plus 1, 2 plus 2. We are going night. Okay? All right. So, but before we get started, I think it is very important for us to just talk a little bit about how do we approach problem-solving type questions. Yes?
I agree with you, Latoya, you know, but we solve problems every day though, you know.
Every day.
Every day. So when it comes to solving problems in mathematics, we need to have a streamlined approach, you know.
Yeah.
So one of the first things we want to ensure, and we know that our students would have heard some of this in a previous lesson, so we're just recapping, right?
Yes.
So we want to first understand the problem.
What the problem I say?
Yeah, because guess what? Once we understand, then we can make that next necessary step,
right? Which
is to devise a plan.
All right, yeah? So what we are going to do?
Decide what steps we're going to take.
All right.
All right. Now, after we do that, of course, that's all probably in the mind to some
jot
extent,
it down
or you jot it down,
right?
But then you need to carry out the plan.
Okay.
That's all the problem I'm going to solve if you know.
So me I do the maths.
All right. So there you go. And then one very important step, Latoya, that our students tend to overlook many times is that once we have carried out the plan, we need to look back.
I love that.
Yes.
I love that because if I look back, I can say, but the answer you're off. It not, no, I'm supposed to get one bigger number.
All right, this doesn't make no logical sense.
Yeah.
Yeah.
Right.
So this is what, and of course, if looking back we realize something is wrong, then we know we have to go back,
start over the process,
devise a new plan, etc.
Because maybe you didn't understand the question to begin with.
Word, true.
All right. So we have our approach and our 4-step approach, and we know what we're going to do, right? But I noticed they said devising a plan. With devising that plan, it means that I need a strategy.
True.
Right?
Yes.
So we have some problem-solving type strategies.
We do.
The list was not exhausted, but we have a few that we're going to share, right?
All right.
All right.
So as we look at this first one, Latoya, choosing an operation, I'm thinking that operations will come up throughout whatever problem we're solving.
Maths we do.
Exactly, it's mathematics.
But sometimes,
yeah, it's a strategy.
Yeah.
All right. Now, here's another one that says draw a diagram. Sometimes you need a visual, not true?
Yeah.
You need to look for something and see what going on.
Yeah.
Yeah. So we need a diagram sometimes. At other times, we may need to look for a pattern. And we know that math is filled with patterns, right?
Right.
So that's another useful strategy that we can use.
Agreed.
Making a list.
Okay.
Shopping list.
No. So I'm looking though and I'm saying, then I could draw a diagram, find a pattern, and then choose an operation from my list. See what I did there?
True, but I like that because many times when we look at questions, it's not just one strategy that we'll use.
Right.
So that combination, it turn up, no lie. All right, so let's look at some others. Working backwards. That's a useful one too.
Yeah, and that comes into the approach when you're looking back to ensure that, so maybe when you get your answer, you can plug in your answer. Like for algebra, you could plug in your answer into the equation to ensure that.
Not just that though, because sometimes depending on how the question comes and the information that you're given, you actually have to use that last piece of information
end result,
to work back to what it is that you were asked for.
Agreed.
So,
yes.
Yeah. Make a table.
All right.
I know that is your strategy, you know, you love tables. And what this does, it helps you to see things a little bit clearer, you know, what's happening here. And it may help you
to find a pattern and choose the operation.
All right. And of course, there's a good old guess and check.
When in doubt, see your way out. Just kidding.
Guess. Guess. And I want to point out that it's not just guess, but it's guess and check.
And it has to be logical guesses.
Thank you. Which brings us to the final one today. Use logics. So whatever we're doing must make mathematical sense.
Reason out the thing.
Cool.
All right. So we have our approach. We have some strategies. Let's jump into a question then now.
And we did say that we're looking at consumer arithmetic and sets. So let's start off with consumer arithmetic.
Makes sense. All right, so Jackson's Chemical Company sells sanitizers in 2 sizes, and we know we cannot have enough of this. The table below shows the prices for each size. So there's a 350 milliliter for $400, and there's a 500 milliliter for $550. Right. And we need to determine which size sanitizer is the better buy. And we need to justify our response.
So, Latoya, when I look at this question, I'm looking, and as a consumer, especially now in the COVID time, sanitizer is very, very important. Yes. So I want to ensure that I'm getting value for the money. Right. Mm-hmm. So as I look at this and I'm trying to decide now, it's asking me for the better buy. So it's one of 2 things. Mm-hmm. Either I'm going to be looking at the same quantity, right, and see
how much,
what are the different costs for the same quantity. Right. So if I use one quantity and bottle A, I pay, for example, $1, and the same amount from bottle B, for argument's sake,
pay $2.
You pay $2, then you know, say,
we are
bottle
for the
A
dollar
is the better buy.
Definitely. But I hear what you're saying, though, but I feel like if I dry something, you know.
All right, so I'm sensing a strategy coming out here. So now that we understand what we're doing, we need a strategy.
Right.
All right, cool. What you suggest?
You know me as the artist. So
AKA
I'm going
artist, people. Yes.
So let's draw a diagram.
All right, cool.
All right.
So I'm looking at this, Latoya, and since we're going to be looking at the same quantity.
Right, I like that strategy.
Right, we're using the same quantity, and then we're going to compare prices for that same quantity.
That makes sense.
Now, when I look at this, we see 350 milliliters and 500 milliliters.
Right.
Clearly, these are not the same quantity here.
No.
But I'm looking and I see that the highest common factor for these values is 50. So
not bad.
I'm thinking that we could actually break apart these bottles of sanitizer into smaller parcels, 50 milliliters each.
All right.
And then we'll compare some prices.
Okay, so we're looking at how much you would pay for each 50 milliliter in each bottle.
There you go.
All right, that don't sound bad. That don't sound bad. So, all right, so for $400, which is within the 350 ml, we have we can get 750 milliliters, right?
Right.
And then in the 500 ml, which is for $550, we can get 50 milliliters of sanitizer.
All right. So even as we look at the diagram, we're seeing the same quantity coming out. Yes?
Right.
So we're comparing the cost for 50 milliliters from the first bottle with the cost for 50 milliliters from the second bottle.
All right.
So this $400, Latoya, basically for me to figure out the cost for one of the parcel of 50 milliliters, I need to share up that $400, don't it?
Yes, we do.
Into 7 equal parts.
All right.
So let's divide by 7.
So you are saying that now the cost for each of the 50 milliliters, if we were to split it up, from the 350 milliliters bottle would be $57.14.
There you go.
Okay.
Now let's do the same for the next bottle. So this $550 is now being divided into 10 equal parts.
Right.
So let's see what that gives us.
$55. So each of the 50 milliliter, if we were to share it up now, would cost me $55 from the 500 ml bottle.
That's it. So let's look now. So if I'm paying $57.14 for 50 ml or milliliter from
the 350 ml bottle.
That's the bottle A, but we don't pay up there.
The smaller bottle.
The next one, I'm paying $55 for 500 milliliters.
The same amount.
But cheaper price. So I would say that the 500 milliliters would be the better buy.
And it's just $150 more.
Yeah, but you know, it works out better, don't it?
It does, it does.
I want to also point out though, Latoya, that another way that we could look at this question, we could actually find out how much sanitizer am I getting for each dollar that I'm spending.
Okay.
Yes, so we could have broken it down to talk about $1. How much sanitizer am I getting for $1?
So I would divide that $400 by the 350 milliliters.
We would actually be dividing by 400. So we would divide the 350 milliliter by 400, and that would tell me what quantity I'm getting.
There you go.
So in that case, I would be looking for which bottle gives me more sanitizer per dollar. And that would be the better buy. But and I leave our students to
we could also look at how much I'm spending per milliliter. So I could also look at how much money I'm spending for 1 milliliter.
Or instead of chunks of 50.
Instead of chunks of 50.
All right, fair enough. But let's continue.
So we agree that the 500 milliliter sanitizer would have been the better choice.
Definitely.
All right. That doesn't sound bad. All right. So moving right along into another activity. A vendor makes chocolate drink using milk and chocolate. 3 cups of milk and 2 cups of chocolate make 4 bottles of chocolate drink. A cup of milk costs $51 and a cup of chocolate costs $86. Now, what is the cost of making 100 bottles of chocolate drink? And what should be the selling price of each bottle of chocolate drink to make an overall profit of 20%? Because it's a business we run, you know.
That's right.
And we're not selling it for less than what we're making it for. We got to make a profit.
That's right.
Right?
But in order for us to know whether or not we're making a profit, we need to actually figure out the cost.
Definitely.
For creating these chocolate drinks.
Definitely.
So let's tackle the first question. Yeah. So they asked us what is the cost for making 100 bottles of chocolate drink.
All right, so we need a strategy.
Yeah.
A strategy I think we can use to do that.
We can probably start off with a table and see if we can find any patterns coming up.
I'm here the table girl, you know.
Yeah, you say table.
Yeah, man.
So let's make a table and see if we can look for some patterns.
All right, so I have an outline of a table here. So we're looking at the number of bottles, cups of chocolate drink, the cups of milk used, cups of chocolate used, and how much money to make those bottles of drink. So we were already told that to make 4 bottles of chocolate drink, we need 3 cups of milk, 2 cups of chocolate, right? And they gave us a unit cost for each of the cup of milk and chocolate.
Right.
So $51 per cup of milk. So we multiply that by 3, added to 2 cups of chocolate, and that's $86 per cup. So it's a total of $325 to make 4 bottles of chocolate drink.
There you go.
All right.
So what if I was making 8 bottles? Because I realize now that we're kind of doing this thing in batches.
Right.
So we have a batch that we make and we got 4 bottles out of that.
Right.
So we do another batch.
Okay.
How many bottles are we going to have now?
Oh, so okay. All right. So
8 bottles.
Right.
So we would have used 6 cups of milk here and 4 cups of chocolate.
Right, because it's twice. So
we're doubling things here. Beautiful.
Okay.
So let's look at the total cost now and see what's happening here. So notice that we're now multiplying 51 by 6.
Yes.
And we're $51. Let me put on my units. And we also multiplied $86 by 4.
Right.
No.
Because we're using 4 cups of chocolate.
There you go.
Yes.
And we're putting it together now and we're seeing that 8 bottles of chocolate drink cost $650.
But I'm also seeing because that 8 bottles is twice the 4 bottles, the cost is actually twice the cost to making the 4 bottles.
So, pattern, we are getting a lot
of
pattern. Let's see what's happening now. So if I made 12 bottles,
right.
All right, so we can fill in 9 cups of milk, 6 cups of chocolate, and I'm expecting that this is going to be
3 times.
3 times whatever was the original. So 3 times or $325 multiplied by 3. All right, so I think we're getting the idea. I think we can filling our table a little bit quicker now, and let's look at what's happening. So we have 16 bottles of chocolate drink costing $1,300, and we have 20 bottles of chocolate drink costing $1,625.
Okay, so do we fill out the table to reach 100? No, man, this seems like it's going to be a long
You are the table girl, you tell me.
All right, so we picked up on a pattern earlier, right? And then now we're at 20 bottles of chocolate drink. But I know that $20 give me $100, which means that 20 into 100 goes 5 times.
All right.
So if I know the cost of making 20 bottles of chocolate drink, then I can find 100 quick and fast, man. Let's multiply that by 5.
There you go. So if we know the cost for 20 bottles, then we can simply multiply by 5 to actually find the cost for 100 bottles. Excellent, girl. You're on a roll. You're on a roll.
Bright girl.
But you know, we would have used that table, but as we said earlier, that's not the only strategy we could use, right? So I'm thinking, Latoya, because I also know that I know the cost for making 4 bottles is $325, right?
Yes.
I could actually figure out how many batches do I need to get to 100.
Okay.
So mathematically, I know that 4 multiplied by 25 give me 100.
Yes.
So it means 25 batches would take me to 100 bottles.
That makes sense.
Yes, so that's an alternative solution that we could use. So I could figure out the number of batches as we're seeing on our screen here. So I would need 25 batches, right?
Of the 4?
Of 25 batches of 4 bottles each, right? And that would have given me the 100 bottle that I'm trying to find.
Yes,
the 100
at a cost of?
So the cost, therefore, can also be multiplied by 25.
Yes.
So $325 for 4 bottles.
Right.
So multiplying that by 25, we have the same answer.
Right. So your approach, and I'm thinking that maybe we could even go ahead and find out what's the cost for making 1 bottle.
Word. We could do that, you know.
So we could actually divide the 325 by 4, find the cost of making 1 bottle, and then multiplying that by 100. 3 strategies, quick and fast.
Quick and fast.
Pick your choice.
Logical.
And logical. Pick your choice.
All right, so let's move on.
So it's a whopping $8,125.
Right.
To make 100 bottles of chocolate drink.
There we go. There we go.
Then the other part of the question asked us, what should be the selling price of each bottle of chocolate drink to make an overall profit of 20%? Because we're not just a giveaway thing, so
no.
We need to make a profit because we're entrepreneur, okay?
Yes.
And the profit is a must.
And the business need to expand,
Yes, yes. I need a whole factory and all right
there
now,
you go.
All right?
So let's talk about this. So we're going to be taking 2 approaches to this particular question.
Yep.
So we know already from the previous calculation that the cost for making 4 bottles of chocolate drink is $325.
Yes.
All right. So they're asking me about the selling price for each bottle, and that simply means for 1 bottle.
Yes, ma'am.
So the cost, I want to figure out first, what's the cost for making 1 bottle of chocolate drink?
All right.
So I think you said it earlier. No?
I did.
You did. So we could actually now divide by 4, and we find out that the cost for making 1 bottle of chocolate drink is actually $81.25.
Not sound bad.
Not sound bad at all. But now we need to apply the profit.
Oh,
so
yes,
we're told
yes.
we want to decide on a selling price. Clearly, we're not selling it for $81.25.
Well, that is true.
So we need to now put on our profit, which is 20%.
Not bad.
So our profit, therefore, the selling price, is going to be now 100% added. We're adding that 20% to the 100%. So we're finding 120% of the cost price here.
So the cost is our 100%.
Yes, the starting price.
Right. And so we're adding on that profit of 20%, which is now giving us a selling price of 120%.
Of the cost price.
Of the cost price.
There you go.
All right.
So the rest is pretty simple calculation.
Yes.
So we have our 120 divided by 100 or...
Because we know percentage is out of 100.
There you go. Multiplied by $81.25. And so we need to sell each bottle of chocolate drink for $97.50.
That doesn't sound bad, man.
Doesn't sound bad at all. But guess what? We have another strategy, don't we?
Of course.
As we're saying, look here. You
strategies,
think one way...
strategies.
All right. Okay, I sense dancing coming on, so I'm going to cut you right there. But let's talk about solution 2. Now, the cost for making 4 bottles of chocolate drink, we know that already.
$325.
$325.
And I want to just point out another strategy that we probably never talk about, but we're using the information that we already have to help us, right?
All right.
Yeah, man. So.
All right. I'm fine with that.
Yes.
But so earlier, we found the cost price for 1 bottle of chocolate drink. Okay. And then we applied the profit.
All right.
But in this case, we're saying we could actually find the selling price for all 4 bottles.
Okay.
So let's do that. So we know that the profit is 20% that was given.
Right.
And same thing that we did earlier, we're adding that 20% to the 100%.
Yes.
And that would give us 120%.
Yes.
Of the cost price, but in this case, our cost price is the cost price for all 4 bottles.
Yes, ma'am.
All right, so it means that when we sell 4 bottles, we must sell 4 bottles for $390. But the question asks us, what should be the selling price for each?
So you know, just divide that by 4, man.
Not true?
Yes.
All right, so 390 divided by 4, what does that give us?
The same $97.50.
Isn't that great?
That's lovely.
So that's one of the things that every time I come here I say this is one of the things I love about math, because there isn't just one approach. You get what I'm saying?
Yes, ma'am.
So you are using one approach, I'm using another approach, and the result...
Are the same.
Are the same.
And you can use another approach and let us know. Yeah.
Yeah, as long as it makes logical sense. There you go.
All right.
So when we come back, I'm sensing something coming up. So I want us to actually bring up our activity 3 with our questions and just get our students to actually look at this question and
choose a strategy.
Try understand the problem first of all.
Yes.
They can compare as well their answers with what we will have.
That sounds like a plan.
Yeah. So Annie went to the post office and bought a collection of 6 of each of the following stamps.
All right.
And people, some of our students might not know about this stamp thing, you know.
Listen, sis. Listen, sis.
But
I don't know about you. Did you used to collect stamps? Me used to collect stamps.
No.
What you say?
No, I'm not a stamp collector.
All right.
But I do, my mom works in the postal system, or used to.
Oh.
So I have an idea about stamps.
That's nice.
Yes. And the fact that, you know, there's a cost for posting certain things, and you have to make sure the stamps, the
So for the youngins at home who probably not understanding what we're talking about, when you're sending a letter over foreign or even Jamaica, you have to put stamps on it. So the posting the letter will cost you depending on where you're sending it, and the cost is usually represented in the stamp value.
There you go.
Okay? Okay.
So we have some nice looking stamps here, yeah?
Yes.
Now, part A asks us, so she bought 6 of each of these stamps.
Beautiful.
And we're being asked to find the total cost of the stamps. And then we're told, as we said, she has to post a parcel now.
Right.
And the cost for postage, the total cost for postage is $25.70. And we're being asked, what stamps can she select from the collection to make up this amount if she must use as many $4 stamps as possible? So we're going to explore that in and of itself. Or another condition, She posting the same package, but this time she needs to use all her $1 stamps.
All right, that doesn't sound bad.
Not sound bad at all. So let's talk.
All right.
Let's talk. So for the total cost of the stamps, you know.
What strategy we're going to use?
Yeah, man, we can always use a number sentence. Choose an operation. That was it?
Yeah.
Choose an operation.
Because this one easy.
Yeah.
Yeah.
So we know she bought 6 of each stamp. So we could have gone ahead, Latoya, and find the cost for the 6 of each of the stamps. So we could have multiplied that $4 by 6.
Yes.
And that $2.50 by 6.
Yes.
And each of those cost by 6.
Right.
And then we could add up all of those values together. On screen, we chose a different approach.
Yes, ma'am.
So we went ahead and we added the values for the stamps first.
Yes.
And then multiply that result. So all the stamps, if you bought 1 of each, would have been $8.70. But we know you bought 6 of each. So we simply multiply that cost by 6. And so Annie would have paid $52.20 for the stamps.
Yep. 24 stamps.
There you go.
All right.
All right, let's look at part B. So we're told that the total cost for the postage is $25.70. But she must use as many $4 stamps as possible. Strategy. Guess what? This one, I think we need to guess. Guess how much we think she could use, and then do some checks and see if we can get that $25.70 that we need.
That sounds like a plan.
All right, so let's go. So we're gonna guess, we're gonna check, and we're not just guessing, we're using logics to make our guess, right?
Definitely.
So guess what? She uses, let's assume, we're a guess. So she used all our $4 stamps. How much she did buy again?
6 of each.
6. So she has 6 $4 stamps. So let's see how that works out. So 6 $4 stamps would cover a cost of $24.
Okay.
So Annie needs $1.70 more to post our parcel.
All right, because the entire cost of the postage is $25.70.
Yes.
Okay.
So looking at this, Latoya, clearly she can't use any $2.50 stamps. That would definitely exceed the amount she's aiming for. $1.20.
That would leave only 50 cents.
And there's no 50 cents stamp there, so that couldn't work. $1 stamp, she would still be short.
70 cents, and there's no 70-cent stamp.
Ouch. Look like we guess wrong, lads.
But that's okay.
It's okay.
It's guess and check. That's okay.
Guess and check.
And I want to also note that we're using a table, so we're actually using 3 strategies in one.
Right.
Yeah, girl.
So we can see that no combination of stamps is giving us that $1.70 total that we would have needed if she used all 6 of her $4 stamps.
Yes.
So this guess ain't right. Let's move to another one. That's fine. So let's try, because it says as many $4 stamps as possible.
Okay.
So if we try 6.
Don't work. Let's go to the
next best guess is 5.
That's
we want as many. All right. So if she used 5 $4 stamps, that would cover $20. She now needs stamps valuing $5.70. So let's pause right here. Let's talk about the $2.50 stamps. She could use 1. She could use 2, maybe, but if she used 2, that would give her $5, and we have a 70 cents hanging there.
I was looking at that 70 cents, and I'm seeing that it has to be a combination of a 50 cents and a 20 cents portion.
There you go.
Right.
So she can't use 2. So let's guess 1 for now. So let's bring in our 1 and see where we are with our total. All right, so we're at $22.50.
But I noticed you said that she can't use 2. Why?
Because she needed $5.70. She needs $5.70, and if she used 2, that would be $5. and we don't have any 70-cent stamps.
Oh, the 50 cents part would, because...
We needed that 50, as you pointed out, that 50 cent and that 20 cent to come together to make that 70 cents.
Makes sense, all right.
So, obviously now our total, $22.50. So, we need $1.20 stamp here. We need that 20 cents.
Yes.
So, let's guess $1.20 stamp and see what's happening with our total. We're up to $23.70,
which means that we're shy of $2 for the cost of the postage.
Yeah, so when I can use two $1 stamp.
Easy.
Yeah.
Package post.
Yeah. All right.
Easy, easy, cheesy.
So we got it on our second guess.
Yep.
All right.
So Annie just needs 5 $4 stamps, one $202.50 stamp, one $1.20 stamp, and two $1 stamps. Boy,
right,
I'm going to bite up my tongue.
All right. Let's move to part B of the next section of part B. So we're still posting the same package, not true?
Right, but they gave us another condition.
Yes, so she must use all her $1 stamps. All her $1 stamps. So again, we're using guess and check logic.
We don't know,
table,
right?
Yeah?
Yeah.
But all our $1 stamp, we must meet that condition.
Which, that is all 6.
That is all 6.
And so right away we know that $6 is accounted for.
There you go.
All right.
So we need to now figure out what's happening here. So let's talk about the $1.20 stamps. You said... So we have $19.70 to make up.
Yes.
You mentioned earlier that we need a 50 cent and a 20 cent to make that 70 cents. So we have to be careful how we choose the number of these stamps that we use.
Agreed.
So let's talk about the $1.20 stamps. I could choose one.
We could.
Because I would have that 20 cents hanging over to add to the 50 cents.
To make the 70, right?
But if I choose 2, I'm going to have 40 cents there, so...
Right.
I mean, I have no 30 cents for any stamp for makeup.
Right, right.
I choose 3, that's 60 cents.
Which you're going to shy 10 cents.
Shy 10 cents.
And we don't have a 10 cent stamp.
If I chose 4, that's going to give me 80 cents, which means I need a whole 90 cents to get back to see. You see what's happening here? So
it's either 1 or all.
1 or all, because if I use 5, that would give me a whole number there.
Yes.
So she must use either 1 of her $1.20 stamp or all 6.
Right.
So I could make a guess now. I could just try one for now.
All right.
All right, so here we have our total cost with that 20 cents hanging over. No, not true.
Yes.
So we're ready to choose our $2.50 stamps. So any number that we choose must have a 50 cent
hanging
to add to that 20 cents.
Yes.
So I could choose 1.
All right.
Yeah, I could choose, can't choose 2, because that would give me $5. But I could choose 3.
Yes.
Yeah.
Or 5. So I'm saying if we choose the odd number of stamps, it will give us that 50 cents hanging.
That we need to add on to that 20 cents to make the 70.
Yes. Yeah, so with that one $2.50 stamps now, we're at a total of $9.70.
So that sounds like we want $16 more to get the $25.
That easy, man, for 416. Quick and fast.
True.
Look at that.
Turn up.
Look at that.
Yes.
So if Annie is going to use all of her $1 stamps, she's also going to be using one $1.20 stamp, 20 cents, one $2.50 stamp, and 4 $4 stamps.
I want to point out though, that there are other possibilities. There's actually another possibility that could be here.
Definitely.
So we leave our students to explore.
Tell us.
Yeah,
tell us.
All right, so let's continue. I think there's another part that we didn't mention earlier. So we're talking about the same package here now. And part C of the question is asking us, what is the largest number of stamps that she can use from the collection to post the parcel?
Largest number of stamps. Okay, all right, you want to fill up the parcel with stamp, not a problem.
So look here now. As I saw this question, I went back to when we're making $100, right? So if I use $50, how many $50 I need to make?
Only 2.
All right, but what if I use $20?
That's a whopping 5.
Ah, because what? The $20 value less.
Right.
And the $50,
and
so
if
I need
use
more.
$10, that's a 10.
Whew, not to mention if I use $5.
What if I use $1?
But what it points out though, Latoya, is that if we want the largest number of stamps, then we definitely have to use up more of the cheaper stamps.
See it there? Cheap and clean.
There you go. So let's talk about it, and then we can list the collection, the stamps that she will use. So in this case, we're starting from the lower value stamps.
Yes, so we're guessing and checking.
Let's start with 6. Let's use all
$6 used.
There you go.
$19.70 to go.
So we need $1.20 stamps, and we said she either must use 1 or
all 6.
So since we're trying to make up whole heap of stamp, let's go with 6.
All right, so we're at $13.20.
All right, number of $2.50 stamps with its
have to use an odd number.
So either 1, 3, or 5.
Yes.
So guess what? At the largest number of stamps. So run with 5 now. Let's run with 5.
What year?
We reach it total.
Question done.
Question done. Just
Pack
like
up and
that.
go home.
Oh my goodness. So how many stamps that now, lads?
So that's 17.
17 stamps. So that's the largest number of stamps that she could use. Let's break down the combination. Huh?
So that's 5 $2.50 stamps, 6 $1.20 stamps, and 6 $1 stamps.
There you go.
Package post.
What do you know? So we did say, Latoya, that we're looking at consumer arithmetic.
Yes.
And we're looking at set theory.
Yes.
All right, so we're going to jump a little over into set theory.
So we finished with consumer?
Yeah. Yeah.
All right.
All right, so let's talk a little bit about set theory, and let's look at a question quickly.
All right. So the Venn diagram below represents the type of games played by members of a youth club. All members of the club play at least 1 game.
All right, cool.
So S represents a set of members who play squash. You know what is squash?
You told me, we talked the other day, didn't we?
Yeah, it's something similar to tennis, but instead of using a tennis ball and batting to somebody across the line, you're actually batting on a wall.
Right.
On a wall.
You did tell me.
So it's something similar to tennis. All right. T represents the set of members who play tennis, and H represents the set of members who play hockey.
All right, cool.
If you were playing, or if you were in this youth club, which one would you play?
Tennis, because I cannot play squash, and I worse can't play hockey, but I would have played a little.
You know, I would choose squash, because squash is usually inside of a building, tennis outside, and sun is going to burn me.
Okay, whatever.
Hockey is just to contact
Moving
for
right
me.
along. Let's continue. So,
all right. So the question is there any member of the youth club who plays squash only? And I needed to justify your answer.
All right, so for this one, I need to touch the screen and, you know, reason
out. So tell me which strategy you're going to use first.
Well, logics.
All right.
Because we have diagram up here already, so it's logics.
All right, and we know that this diagram is from Mr. Venn himself.
That's right.
It's a Venn diagram.
So let's use the logics on this. So you're asking me, is there a member of the youth club who plays only squash? So I'm looking here and I'm seeing the set for the squash, the students, the club members who play squash. But you said squash only.
Yes.
So obviously I can't choose this section right here, which is the intersection.
Right, intersection of what though?
We'll talk about that in a few, but not intersection at all, because we say squash only. So,
all right.
So I'm looking at out here.
Right.
But, Latoya, I'm looking everybody who plays squash, them in the tennis set. So squash is a subset. The set squash is a subset of the tennis set.
Might as well, because the two are them.
So guess what? Everybody who plays squash play tennis.
So the question still lies, ma'am. Is there any member of the youth club who plays only squash?
No. A whopping no.
Is this your final answer?
Final answer.
For $1 million? Or no?
I just wish you had $1 million to give me. But that's my final answer. All
right. So there is no member of the club who plays squash only, because as you rightly said, squash, the persons who play squash also plays tennis, because squash is a subset of tennis. You is a bright girl.
I know, right?
All right. So I'm going to give you some what you call it now? Some descriptions, and I want you to place the following members on the Venn diagram based on their description.
All right. That doesn't sound bad.
And I think you can just use logics to do this one. Yeah, so Kim plays hockey and tennis only. Where are you going to put Kim?
Hockey and tennis only. So that means that Kim don't play squash. First thing I noticed. So Kim cannot be in the squash circle at all.
All right.
So, but she can't be only tennis either or only hockey. So she must be somewhere in the intersection here. But since she doesn't play squash, she would have to be somewhere, right?
Is that your final answer?
Final answer, girl.
500,000 would I know, you know? All right.
You love betting, you know? I wish I had the money to give me, you know? I would surely bet with you.
All right.
But that's my final answer.
That's Kim.
All right, let's talk about somebody else.
All right, Mary plays tennis only. And I'm very curious to see where you're going to put Marie.
Tennis only. So clearly, Marie not in squash, Marie not in hockey.
Okay.
But she in tennis. So
but squash people play tennis?
Yes, squash people play tennis, but it's not every tennis person play squash.
Okay.
So Marie look like she have to itch up somewhere out here, so.
Is that your final answer, ma'am?
Yeah, man. Final answer.
Deal or no deal?
Deal.
All right.
Oh,
and
great.
That's Marie.
So let's do the last person.
Carlos.
Carlos plays all 3 games. Who? So he must be in squash, he must be in tennis, he must be in hockey. So first of all, I must be looking at somewhere in some intersection going on right here. So Carlos must be somewhere here, but I need to figure out where.
Right.
So we had Kim here, and she played hockey and tennis only. So Carlos can't be here. So guess what? Carlos must be here because Carlos must be in hockey, he must be in squash, and tennis at the same time.
Is that your final answer, ma'am?
Carlos right there, so. Final answer. Final answer.
I wish I had the million to give you.
You see how logics work.
Use a bright one.
Yeah.
All right.
So that's why we're looking at solving problems involving consumer arithmetic and set theory.
Yes.
And we're on to our final activity focusing on set theory.
And I have just a question for you.
All right.
150 first-year college students were interviewed. 85 were registered for a mathematics class. 70 were registered for an English class. And 50 were registered for both mathematics and English. How many signed up for neither mathematics nor English?
So that's why I'm looking at this, and it's a lot of information to process, because the first thing I noticed is that it's 150 first-year students, 85 registered for math, 70 registered for an English class, and already I'm over 150 persons. Did you see that? So clearly, and they did say it, 50 were registered for both mathematics and English. But we also know that there may actually be some that didn't register for either math
Unfortunately.
or English. So look here, for me to, pull this together, I need a diagram.
Okay.
Really, you're the table girl, but I really need a diagram right here.
So you're going to call Uncle Venn?
Calling Uncle Venn, because we're going to be doing a Venn diagram.
Not a problem.
Now, I know that this diagram, I need to have overlapping circles for this Venn diagram. How I know that? 50 students were registered for both mathematics and English. So, you know what? Let's work. We're kind of working backward here, so because we're working from the last piece of information.
All right.
So let's start with our 50 students in the intersection of our Venn diagram. All right. So 85 students were registered for mathematics, suggesting to me that 50 of those students, we account for them already.
Yes,
because they would be the ones that do both math and English. So therefore, to find out those who belong to mathematics only, or the registered for math only, I would need to take out those 50 students out of the 85 students who registered for math in total.
Okay, we don't want to double account.
There you go.
Right.
So let's see how many registered for math only. 35 students, all right?
And when we sum that 35 and 50, we are still getting back that 85 students total who did math.
Very
or
important.
Registered for math.
Very important point, Latoya. So let's jump over because we want to figure those who do English only.
Right.
So we have 70 students who were registered for English, but those 50 students right here are in the English class, or they're registered for English.
Right.
So they are included in this 70 student, these 70 students right here.
Yeah.
So I need to figure out those who register for English only. So I need to take out those 50 students, and that will leave 20.
20. And again, when I'm looking at those students who registered for English on the Venn diagram, that 50 added to 20 is giving me the 70, which the question would have told us about.
Beautiful. So let's see now how many students we have accounted for thus far.
Yes.
So we have our 85 students, 35 added to 50, that gives us 85, added to 20, giving me 105.
Okay.
What is 150 students?
Okay.
So that means that 45 students are there that we didn't account for.
Where you get that 45?
Because it's 150 students and I have 105 students in the Venn diagram already. Yeah.
Okay.
So I need to take out that 105 out of that 150 and the remaining students, that 45, must be those who do neither math nor English, or didn't register, let me fix that, for math nor English. So they would be right here.
Right
in
where?
our Venn diagram, outside of the math set, outside of the English set, but within the universal set, because they are in the total.
Got you.
Got me.
And then if we sum up, and then we can now go ahead to look back, as we would have said in our approach.
True.
Sum all the numbers on the Venn diagram to ensure that we get our 150 students who would have been interviewed.
There you go.
And the question is finished.
So important the check back is though, the look back in the strategy, because what if I made a calculation error and I didn't get that 45?
There you go.
So we would want to double check and ensure that.
There you go.
Things legit and start out, don't?
Yes.
So it has been a morning.
It has. Had a time.
We've been looking at problem solving with questions on consumer arithmetic and set theory.
Yes.
But you know, we want to ensure that we leave our students with two very important pieces of information.
Definitely.
How do we approach problem solving? So we want to ensure that we understand the problem, devise a plan.
Yes, ma'am.
Carry out the plan.
Yes, ma'am.
And make sure you check.
Make sure.
Yeah, look back, double check.
And I want to say, in your devising of your plan, you probably want to estimate what your solution should look like.
All right, you could.
So when you get to the point of carrying out the plan, you could say, when you're looking back, you say, no man, this not seem right. Something, the answer you're not look right.
Yes, definitely. And we also want to leave them with the strategies, some of which we would have used this morning as we explored problem solving. So you may want to, well, not me, because it's math. So you're going to choose an operation, clearly, but this may be coupled with some of these others.
Yes.
So you may need to draw a diagram.
And I always say, if you can draw it, it makes it a little bit more easier for you, because you can see.
The visual is important.
Very.
You may want to find a pattern.
Yes.
Make a list.
With your pattern, draw and choosing of an operation or whatever else you need on your list.
You may want to work backward based on how the information is given. You may have to work from the very last piece of information back to what the question requires of you.
Yeah.
You might want to make a table. Guess, but don't just guess alone.
So when in doubt, don't see your way out?
No. You can guess, but you need to check. So it's guess coupled with check. And of course, use logic.
It's maths, so aphorism is not the thing.
There you go.
Had a time. I hope you had a time too. And we're out of time for this lesson. Thank you so very much for joining us today. Keep practicing, okay?
And stay safe. Wash your hands.
Sanitize.
And
wear your mask.
Bye.